Okay, we're going to continue our study of what is weather with pages, I believe it's 38 and 39. You left off on your outline from Thursday with air temperature and wind. We need to draw this picture. Remind me in the morning that we need to draw this picture of how the air molecules move if the temperature is hot or cold, because that is what we're going to look at today. All right, so you are on page 38 in your book. You have it open in front of you. We're going to read about humidity and then something that's a little more specific called relative humidity. Okay, we all know that heat evaporates water into the atmosphere. Where does the water go? Water vapor molecules fit into spaces among the molecules that make up air. The amount of water vapor present in the air is called humidity. Air doesn't always contain the same amount of water vapor. As you can see in figure 3, more water vapor can be present when the air is warm than when the air is cool. At warmer temperatures, the molecules of water vapor and air move quickly and don't easily come together. At cooler temperatures, molecules in air move more slowly. The slower movement allows water vapor molecules to stick together and form droplets of liquid water. The formation of liquid water from water vapor is called condensation. When enough water vapor is present in air for condensation to take place, the air is saturated. Okay, there was a lot of information, and we have a definition in here. Our definition is what is humidity, so we'll make sure we write that down. And then we have a comparison in this paragraph. What are the two things we're comparing? We are comparing the amount of water vapor when the air is warm and then when the air is cool. So we're going to identify what happens when the air is warm, why can the air hold more water vapor versus cool. Let's take a minute to look at figure 3. Okay, I see this kind of as a game of tag. When the air is warm, the water molecules are moving around a lot among the air molecules. Remember that high temperature comes because the air molecules are moving around so much they create heat. We feel that warmth. So the water molecules are moving around and they can't touch each other. Okay, kind of like a big game of tag. When they are moving slower because it's cooler, the water molecules can come together more easily to form water droplets, and then the air will condense. Tell me tomorrow what you saw this morning. This morning when you woke up, what did you see outside? Alright, so here come our notes. Okay, humidity, here's our definition. The amount of water vapor in the air. Alright, now we're going to compare our warm air and our cool air. And here's my mistake. That should be a C. Alright, so warm air, the molecules move faster. The vapor does not come together easily. And cool air, the particles and molecules move slower, so the water vapor comes together easily. Okay, notice you have does not come and does come. So this should be a D. Saturation is when enough water vapor is present and condensation occurs. Okay, when you see dew on the grass, that's because the air near the grass is saturated with water vapor. Pause it and come back when you're done writing. Alright, there's our figure, which you already looked at. Alright, relative humidity. This is some math. On a hot, sticky afternoon, the weather forecaster reports that the humidity is 50%. How can the humidity be low when it feels so humid? Weather forecasters report the amount of moisture in the air as relative humidity. Uh-oh. Oh my goodness. What just happened? Oh boy. Alright. Relative humidity is a measure of the amount of water vapor present in the air compared to the amount needed for saturation at a specific temperature. If you hear a weather forecaster say the relative humidity is 50%, that means the air contains 50% of the water needed for the air to be saturated. As shown in Figure 4, air at 25 degrees Celsius is saturated when it contains 22 grams of water vapor per cubic meter of air. The relative humidity is 100%. If air at 25 degrees Celsius contains 11 grams of water vapor per cubic meter, the relative humidity is 50%. Okay, that's a lot of blah, 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 because this is all math problems, and math problems are much easier to understand when we have a math equation. So, when you see this word compared right here, that's division. Alright, so the amount of water vapor in the air divided by the amount needed for saturation. We're going to look at this table here in a minute, but if you take what you know, that the amount of water vapor, the cool air can hold less vapor, and warm air can hold more vapor. As the temperature increases, the amount of water vapor required increases as well. And we will do some work with this down here, so you don't need to understand that right now, but we will do some work with the math to understand it. So, here we go with relative humidity. Alright, D, relative humidity. A, the relative humidity depends on air temperature. It is the amount of vapor divided by the dew point, which we don't know yet, but that is the short term for the saturation levels. And relative humidity is a percent. It is how much of the air contains water vapor compared to how much it can hold altogether. Alright, let's look at Figure 4. Alright, so this dew point is what we were saying. So the cooler the temperature, the less water vapor the air can hold before it condenses. Remember, these are the guys that are cold. Whoops. These are the guys, the air molecules that are cold. They're standing around. They stick together. The warmer the air gets, the more they move around. They can't touch each other. They can't stick together. So there are more of them. Eventually, they all start colliding with each other. So these are the numbers that indicate what the saturation point is. So at 35, let's do 40. 40 degrees Celsius, the air can hold 50 grams per cubic meter of water vapor. All right. If it only held 25, then it would be at 50%. All right. You just get a general idea of this in the terminology. All right. Last thing we're going to do is dew point. Okay. When the temperature drops, less water vapor can be present in the air. The water vapor in air will condense to a liquid or form ice crystals. The temperature at which air is saturated and condensation forms is the dew point. The dew point changes with the amount of water vapor in the air. You've probably seen water droplets form on the outside of a glass of cold milk. The cold glass, the cool of the air next to it, is its dew point. The water vapor in the surrounding air condensed and formed water droplets on the glass. In a similar way, when air near the ground cools to its dew point, water vapor condenses and forms dew. Frost may form when temperatures are near 0 degrees. We have a definition, and we'll write down that definition, and we will kind of come to a little summary. All right, I think we're on big number 2. I wasn't sure if that was right. So dew point. Temperature, the dew point is the temperature when air is saturated and condensation occurs. So, last night, we woke up this morning, what was the grass like? B, cooler air holds less vapor, therefore has a lower dew point. Okay, because the water vapor comes together when the cool air, so it will hold less. Warmer air holds more vapor, therefore has a higher dew point. All right. Now, question for you. You will have to be prepared to answer this Tuesday morning in class. When you wake up in the fall and the spring, you probably see dew on the ground. Do you see dew in the summer? Why or why not? So this is very appropriate because I believe there's supposed to be frost actually tonight. Anyhow, hope you have a great evening. We have 5 days this week, but next week's kind of an easier week. Hope you have a good evening and make good choices and go to bed.